And the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, everybody. Today's the review day. So ask away whatever questions you have. Bring them on.
I have a question on the review on the number 23.
Okay, let me pull that up for you here. And let's see here. Come on, here we go. I think you're in the first class. Yeah, there you are. Okay. And you said number 3, no, 23. 23 on the chapter review. Okay, it's coming up here. Okay. 23. Come on. Yes, this fun one. Okay, he has an evil laugh. So let's take a look at it. All right. 23, solve the absolute value. Enter your answers as a comma-separated list. If the answer does not exist, write or enter D, N, E as does not exist in capital letters. Okay, so let me copy this down and then we'll go through it together. So we've got the absolute value of 6 times the quantity 1 minus x plus 1 all over 6 equals the absolute value of 7x minus 2 all over 7. Okay, let's go back to the whiteboard and take a look. So the rule was when you have 2 absolute value terms in an equation, you want to separate them. These are already separated. This is a 6. Let me write that a little better. And so then we're going to have 2 possible equations. One of them is going to be whatever is in the first one equals whatever is in the second one. Or we could say whatever is in the first one equal to the opposite of whatever's in the second one. Now, notice I put the subtraction sign out in front. I could either do that or I could have written it like this, where I would group the entire numerator, because that negative sign or minus sign or subtraction sign goes with the whole numerator, okay, which is where I'm going to put it in the next step. All right, so let's go back and take a look at this first equation here. I'm going to simplify the numerator on the left, so I'm going to distribute. I'm going to get 6 minus 6x plus 1 over 6. Oops, I wrote 6x. Sorry. Okay, so I'm going to get 6 minus 6x plus 1 over 6, which could further be combined into what? Negative 6x plus 7 over 6, combining like terms, equals 7x minus 2 over 7. Okay, now I've still got a long ways to go, but I've simplified that left side term, the numerator there. All right, now I have an equation that contains fractions. I want to clear the fractions. So I want the least common denominator of the 6 that's in the first denominator and the 7 that's in the second denominator. And that would be 6 times 7 or 42. So my next step is going to be to multiply both sides by 42. Okay. Now when I do that, on the left, The 42 and the 6 reduce down to a 7 over 1. And the 42 over 7 reduced down to a 6 over 1. So what have I got now? On the left side, I've got 7 times the quantity negative 6x plus 7 all over 1. Well, being all over 1, I can actually just get rid of the denominators, right? Okay. So I've got 7, let me just rewrite that. 7 times negative 6x plus 7 equals 6 times negative, or 7x minus 2. Okay? Still working on that first equation. So now, distributing, I get negative 42x plus 49 equals 42x minus 12. I'm going to go ahead and put the x's on the left. So I'm going to subtract 42x from both sides of the equation. I get negative 84, negative 84x plus 49 equals negative 12. Okay, I'm going to subtract 49 from both sides, and I get negative 84x equals negative 61. Okay, then I'm going to divide both sides by negative 84, and I get x equals 61 over 84. 61's prime, 61 over 84 doesn't reduce. Okay, so my first potential solution is 61 over 84. All right. So let's do this. I'm gonna circle that in red as saying that's a possibility. Now I'm gonna go to the next page, and I'm going to take this equation with me that I haven't solved yet. Okay. Because there's no way I was going to get this all done on one page. So let me recopy that on the next page. So I've got, 6 times 1 minus x plus 1, 1 minus x plus 1, all over 6 equals, let's see, negative outside. So, oops. Oh, wait a minute. My bad. Going back and forth like this, I don't have the absolute value bars, do I? The disadvantage of small pages here. So I've got a negative, and then 7x minus 2 all over 7. Okay, let's make sure I got that copied correctly. 6 times 1 minus x plus 1. 7. Okay, I think we're good. So now let's solve this one. On the left side, again, I'm going to distribute. I'm going to get 6 minus 6x plus 1 over 6, which is negative 6x plus 7 over 6 equals. I'm going to distribute. So instead of being negative the whole thing, it's going to be negative the numerator, okay, which is going to be negative 7x plus 2 all over 7. So far, so good. Okay. Now I'm going to multiply both sides by 42 again. On the left, 42 over 6 is 7. So I've got 7 times negative 6x plus 7 equals, on the right, 42 over 7 is 6 times negative 7x plus 2. Okay. So now I get negative 42x plus 49 equals negative 42x plus 12. Okay. Let's see. Let's put all the x's on the left. So I'm going to add, I'm running out of room here, 42x to both sides. Oh, when I do that, on the left, I get 49, and on the right, I get 12. Well, 49 doesn't equal 12, does it? So that is a dead end. So there's no solution for that one. So my only potential solution is this one right here, x equals negative 61 over 84. Okay. So now what I've got to do is I've got to plug that into the original equation. And I want to mention something because I just emailed a student earlier today that was having a question about a similar problem. When you're checking your work, you plug it back into the original equation, not the two new equations that I created, the original with the absolute value bars, okay? So now let's see what happens.
Just so I'm correct, can you go to the other slide? You kind of went too fast down this
Right.
one. So where it says 6 negative 6x, you took out the 6 on top? Because on the bottom it's already. Oh, I was like, you went too fast. I'm like,
All right.
okay, I got it now.
Anytime I'm going too fast, just tell me to slow down right then. You don't have to wait till I'm done. So wait, hold it on. It's okay. All right. I won't freak out too much. Okay. So we okay to go back to the other screen or more questions there?
We're okay. Thank you.
Okay. All right. So we're back here and we're trying to determine whether this answer right there is correct for this equation. Okay. So I think what I'm going to do now, let's see here, is I'm going to erase all this stuff. I'm thinking maybe that'll take less time than to go back and forth and recopy everything a million times. We'll see. We'll see. I may regret this, but oh well. Okay. There we go. All right. So I'm going to take 61 over 84 and put it in the place of x. So that's going to give me this. 1 minus 61 over 84 plus 1 equals 7 times 61 over 84 minus 2. Okay? Does that look right so far? All right. A common mistake might be to go over here and say, oh, those will cross out and those will cross out, but they don't, do they? Because that 6 on top isn't being multiplied by everything. So you can't do that. Okay. So let's see what's going on here. 1 minus 61 over 84. Let's take that little piece there. 1 minus 61 over 84 would be 84 over 84 minus 61 over 84. What am I doing? I'm getting a common denominator. So I'm taking 1 and turning it into 84 84ths. Okay. So 84 84ths minus 61 84ths would be what? 23 84ths? Is that right? Oh, I guess it's all right. Okay. So now I have this. I have 6 times 23 84ths plus 1 all over 6 equals, okay? Continuing on the left side, let's see. 6 times 23 over 84. 6 goes into 84 exactly. Let's see, 10, 14 times. Check it out. 6 times 14 is 84. So this is going to reduce down to 1 over 14. Okay. So now on the next, so I'm going to get what? 20, let's see. This is going to be 23 14ths. Okay. So what happened here? Oh, I was going to go to the next page. Let's see, 23 14ths plus 1. So I've got 23 14ths plus 1 all over 6. Okay. Let's see. 23 14ths plus 1 would be 23 14ths plus 14 14ths over 6, which is 37 14ths over 6. I'm still working on the left side of the equation. This was awful, isn't it? I know you're thinking, yeah, you assigned it. Okay, let's see. 37/14 divided by 6. This is where somebody steps in and says, you know, you made a mistake back there in that page you erased. Would be 37/14 times 1/6, which would be 37 over 84. So going on, we've got the absolute value of 37 over 84, which is 37 over 84. Okay, so that whole mess on the left side simplified down to 37 over 84. And I know I probably went quickly here. Fortunately, it's all on the video, but let's go all the way back to here. So now the hope is that we can get that to be 37 over 84. Let's see what's going to happen here. Okay. So I'm going to take this thing, 7 times 61 over 84. 7 goes into 84 12 times. So this becomes 1 over 12. So I've got 61 over 12 minus 2. So 61 over 12 minus 2 all over 7. Okay. Still with me? All right. Yeah. Okay. So 61 over 12 minus 2 would be, let's see, 61 over 12 minus 2 would be 61 over 12 minus 24 over 12. Okay, because I'm going to take 2 and multiply it by 12 over 12. What's 61 minus 24? That's 37 over 12. Okay. But that was just, let's see here. I'm really lost. I'm sorry. That's 37 over 12, but then that was also over 7, right? So I've got, I have 37 over 12, but that was all over 7. Okay, remember that? So that's 37. What's that?
Oh, no. I was just agreeing.
Okay. So that's 37 over 12 times 1 over 7, which is 37 over 84. And it checks. And that was awful. I'm sorry, jumping back and forth there. If I had to do that over again right now, I think I'd write a lot smaller and try and cram more on a page so that I wasn't going back and forth and getting us all confused. My point is this. Okay, the answer did work, a single answer. Let's go back up here. We came up with 2. Oh, that's true. I erased it all. We came up with 2. I knew I'd be in trouble. Came up with 2 equations. One of them led to a dead end when it ended up being a number equal to a different number. So it wasn't true. So that's saying that's not going to work. There's no solution to that equation. The first one led to this 61 over 84. And that was still horrendous to have to deal with, to plug in, but we got there. Okay, have I got you completely confused now?
I think I got it.
Just one other thought, okay, that maybe I should have done this in the first place. Of course, hindsight's 20/20. Let's go back for just a minute, and I want to take the original equation. What I could have done before I split it up is I could have dealt with this whole mess. And I could have said, well, that's what, 6 minus 6x plus 1 over 6. And that's negative 6x plus 7 over 6. And so I could have written it like that. In other words, simplifying that and then split it up. That would have saved me some room, some time. It's all this pressure of, you know, all of you folks there and everything. And I buckled under pressure. I'm sorry. Anyway, but yeah. We could have simplified that first inside the absolute value bars. So then I would have gotten that equals that, which I eventually did, and then or that equals, and then I could have done this. Okay, and gone from there. That would have saved some messy work. Okay with that?
Yes.
All right. Sorry about that. What else you got for me?
Would you also do that 25? Oh, sorry, someone else. Sorry.
Okay. I'm seeing it looks like somebody put a message in the thing there in the chat room, and I don't normally check the chat room because I've got so much going on anyway. So if you wouldn't mind speaking up, whatever. Okay, what is it? You said you wanted another one like that?
No, I was wondering if you'll be able to do a the 25. It's the story problem.
That same 25 there?
Yeah.
Okay, let's see here. Okay, hang on just a second. Can you do 24 and 25 from the review? Like, isn't working. Okay, sure. Now, let's see here. Close that. And okay. So, actually, somebody asked for 24 and 25. So I'm going to go ahead and do the 24. And then if it's a different 24, I can do that as well. It says the property tax in a certain country varies directly as assessed valuation. Okay. So we've got property tax. Let's call that P for property tax. Varies directly as assessed valuation, and assessed valuation, we'll call that A, okay? So P stands for property tax, A stands for assessed valuation. It says the property tax in a certain country, I keep wanting to make that county and it's not, country, so P varies directly as assessed valuation. So P equals KA. Don't forget, K is involved, whether it's mentioned or not, in all these formulas to do with variation. All right. It says if a tax of $1,605, so that's P, right? Property tax. So $1,605 is charged on a single family home assessed at $90,000, so K times $90,000. Determine the property tax on an apartment complex assessed at $192,000. Okay, before we can do that last part, we have to determine K. All right, so I've got $1,605 equals K times $90,000. So we're going to come in and divide both sides of this equation by $90,000. You can't see my writing? Sorry. Well, I'm just having an off day today, aren't I? Okay, how about that? We okay there? So property taxes P, assessed valuation is A, P equals KA. It said the property tax was $1,605 for an assessed value of $90,000. We divide both sides by 90,000 and we get K equals, let's see, if I reduce $1,605, let's see here, so 1,000 on my glasses.
How did we figure out which variation it was?
Okay, let me go back to, and don't let me forget to go back to, okay, so the original problem said right here, varies directly.
Oh, okay.
Okay?
Yeah.
All right, so now let's go back to the whiteboard screen. And it says K equals, so I've got to take 1,605 divided by 90,000. And I get this number that's like 0.0178 and then a whole bunch of threes. So what that tells me is that it's not going to come out nicely. It's got a repeating number. So what I need to do, all they're looking for is a final answer. So what I'm going to do is I'm just going to leave K as this whole big number. I can get rid of the dollar signs. And I could reduce that down. For instance, I could take 1605 divided by 5, right? And 90,000 divided by 5. But they're not really asking me to find K, so it's not critical for me to reduce it down to its simplest answer. Okay. I'm just going to use that whole big number. Like I said, I could reduce it all down, but the follow-up said determine the property tax on an apartment complex assessed at $192,000. So they want the property tax, and then for K, I'm going to put in this. And then A, the assessed value is $192,000. So now I'll bet it comes out nice. 1605 times 192,000 divided by 90,000. And I get 3424. We okay with that? And I suppose if I wanted to, I could have reduced out, taken out 3 zeros right there to make it smaller. I'm not saying it's a bad thing to reduce that. I'm just saying I didn't really need to. You okay with this one?
Yes.
All right.
Yeah, can we do another problem?
Yeah, I'm going to do 25, and then I'm going to go another student there. I'm going to go and look theirs up and do those instead if the numbers are different.
Okay.
Okay, so number 25. Let's go back to the WebAssign screen. And let's see, I got to move that so that I can see the problem. For a fixed voltage, the current in an electric circuit varies inversely as the resistance in the current. Okay. So voltage is fixed. The current, so we're going to let's see. C is going to be current, and I know you can't see this. I'll get to there. It varies inversely as the resistance, and we're going to let R equal the resistance in a circuit. Okay, so the current varies inversely as the resistance in the circuit. So the current varies inversely as the resistance. Okay, so my formula is going to look like this. Okay, I'm going to use C for current and R for resistance. Again, it says the current varies inversely as the resistance in the circuit. Are we okay with that?
When we do inversely, we always write it like this.
Mm-hmm.
Like, say it was another letter or another word,
Yep.
we would write it like this. Okay.
Okay, time out. Let's go off on the side for a second here. Direct variation, y equals kx. Inverse variation, y equals k over x. Joint variation, y equals kxz. So k is always present, k is always on top. Now, your x and y variables, those are just variables given in the textbook in general. But for each specific problem, it may have different variables. For instance, the one we're looking at right now, it's talking about current and resistance. So, you know, I suppose I could let y equal the current. I just thought it was easier to use a letter that, you know, stood for it, kind of thing. Does that make sense?
Yeah, but like when it comes to the numbers, when we plug in the numbers, you can put them anywhere, each one.
No. Okay. This is why I'm taking the trouble to label things. Now let's go back to the WebAssign page. Okay. Problem 25, it says, if a certain circuit has a current of 3.5 amps, okay, so 3.5 amps is going to go in the place of C, all right? Because that was the current.
Yeah.
So C is going to be 3.5 amps. When the resistance, which is R, is 130 ohms. Okay, so you see I got this current is 3.5 amps, resistance is 130 ohms. So now going back here, we're going to put in 3.5 equals K over 130. All right, you see how I did that?
Wrong.
What's that?
If we accidentally flipped them, we would get the answer wrong. Say we put 130 where we put R where the C was and C where the R was.
Funny thing, okay, because of the way this problem is set up with the proportion kind of thing, I think you actually would get the right K value, but technically it's still, you're not doing it correctly. Okay, label stuff,
Okay.
make sure you're putting the right numbers in the right place.
Okay.
Because for instance, if and this goes back to like a Math 75 situation, if you wrote it this way, which is not correct, you'd still multiply these two together to get K. And so you do get the right value for K, but I think you'd get in trouble in the next step. Okay.
Oh, okay.
All right. So what am I going to do now? Next thing I'm going to do is I'm going to take 3.5 and change it to 3.5 to make it easier, because my next step, I'm going to multiply both sides by 130. Okay. So K equals 130 times 3.5, which is 455. All right. Now that's going to go up here. So that's my formula moving forward. Okay. Now it says, find the current in the circuit when the resistance is doubled. So what's 2 times 130?
260.
Right. So if we double the resistance, C is going to be 455 over 260. And let's see what we get there. 455 divided by 260. So the current is 1.75, and that is amps. Okay. So by doubling the resistance, it cut the current in half. We okay with this?
Yes.
Yes.
All right.
I got a problem.
Okay, hang on just a second. I had a request. Let's see if that person is even still here. Okay. Let me time on just a second here. All right, I want to go back to just that screen, and I want to look up some other stuff in WebAssign that somebody asked for. So hang on just a minute. Okay, in the other class. And chapter review. Okay, let's see here. So the person that sent me a message through the message thing here asked to look at 24 and 25. So this is yours. I see that you got them correct. Do you still want those examples or not? Okay. Well, I'm going to go on then, because They got them right, and the numbers are similar. So what's another question somebody has?
8.9, number 14.
Okay, let's see here. 8.9, number 14. All right, now you've got the correct answer, but you still want me to do it, right?
Yeah, I struggle with
Okay,
it.
that's fine. That's fine. Just making sure. Okay, so let's pull this down here. And all right, so number 14. Okay, solve the problem by writing a variation model. Under constant temperature, the volume occupied by a gas varies inversely to the pressure applied. So we've got volume, which I'm going to call V, and pressure, which I'm going to call P. Okay? And it says the volume varies inversely to the pressure. So V equals K over P. All right, so that gives me this. Okay? Okay so far?
Yes.
All right. Now, if the gas occupies a volume of 20 cubic inches, so that 20 goes in the place of V, under a pressure of 7 pounds per square inch, so 7 pounds goes in place of P, find the volume when the gas is subjected to a pressure of 10 pounds per square inch. Okay, so again, it said the volume is 20 cubic inches, so 20 went in the place of V, and the pressure is 7 pounds, so 7 went in the place of P. Okay, I'm going to solve for K by multiplying both sides by 7, so I get 140 equals K. And then that goes back here, so now my specific equation looks like that. Okay?
Okay.
Then it says, find the volume when the gas is subjected to a pressure of 10 pounds per square inch. Okay, so the pressure is 10 pounds per square inch. So the volume is going to be 14 cubic inches, which if we go back to the web assigned screen, we see that the correct answer is 14 cubic inches. All right.
All right.
Next question.
Can we do number 1 on the review?
Sure. Was that Alana that just asked?
No, Sarah.
Oh, Sarah, I see there. Okay. Sarah, okay, number 1 on the review. Do you want to do your specific one?
Yes.
Okay, so let me find you here. Actually, I need to make sure I'm not showing the web assigned screen. Okay. Sarah, is it Alvarez?
Yes.
Okay. So much for staying anonymous, huh? Okay, you said number 1 on the review.
Yes.
Okay. So let me make sure I've got the right question. So is it this one?
Yes.
Okay. Now, they tell us, it says let f of x equal 5x plus 4, and g of a equal a squared minus 4a plus 4 all over 5. Find the function value, and they say find g of 7. Okay, are we going to do anything with f of x? No. Why is it even there? It's there to confuse me. No, it's not. Sometimes you have to look at information and figure out what are you going to use in a situation, what aren't you going to use, okay? Since they're asking g of 7, we're going to use the g of a function, not the f of x function, okay? So your first thing is that you've got to choose which thing to use, and that's this one here, okay? So now g of 7 would be 7 squared minus 4 times 7 plus 4 all over 5. I'm not going to use this. If it said find f of something, then I would use that one. All right, simplifying, we get 7 squared is 49, minus 4 times 7 is 28 plus 4 over 5. 49 minus 28 is 21. 21 plus 4 is 25, and 25 over 5 is 5. So g of 7 equals 5. Okay?
Okay, thank you.
You bet. What else? What's next? Anybody? Do you have any general questions about it? Yes, go ahead.
Can you kind of do the graphing, that graph the functions, kind of like if different ones, just so we can see? I mean, I can see.
Okay. So let's see here.
Anyone will be fine.
And let me just to make sure I'm understanding what you're wanting. So for instance, like this problem number 3 that's there.
Yes, just
Yeah,
a little review.
So graph the function, okay. And you don't care about which specific ones I do?
No.
Okay, all right, then let's do this. Let's go back to my whiteboard screen. And let's take a look here. All right. How about this one? Let's see here. F of x equals negative x plus 2. Okay. Now, do you want me to use slope-intercept form, or do you want me to use finding ordered pairs and plotting points? I can do it either way.
The slope.
Slope-intercept form? Okay.
So if we find any graph, we can just choose what we want?
Yeah, you can do it either way.
Oh, okay.
Tell you what, I'll do it both ways, just to, again, and I think I did that way back when. So if I use slope-intercept form, this is like y equals mx plus b. The slope is the coefficient of x, which is -1, and b is the y-intercept, which is 2, okay? So to graph this equation or function using slope-intercept form, the y-intercept is 2, and the slope is -1, meaning it goes down 1 and over 1, 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 okay? And then I'll just line up those points, and it doesn't really matter. The more points I plot, the easier it is to graph it. That's why I plot so many points, okay? So there's the graph of f of x equals negative x plus 2 using slope-intercept form, okay?
Question. When we use that and it's time for us to graph it, because if we make a line, it will only allow us to put 2 dots before it creates the line. And here you put a lot. So which
Okay, again, yes, I understand what you're saying. I'm graphing a lot of points to make it easier for me to line up the ruler that you can't see that I'm using. But yes, let's hang on here. Yes, that's a good point. I should do it the way you have to do it when you're in WebAssign. So, hang on. Okay, so my y-intercept is 2, the slope is down 1 over 1. Okay, so there's my 2 points. See, it's taking me longer to line things up because I've only got 2 points there. All right, you okay with that?
Yes, thank you.
Yeah, no, and I'm glad you clarified that because when you put a whole bunch of points on there, WebAssign doesn't like it. So I'm glad you said something. Okay, now,
But on this one, we can use points and then put the line, right? Not like
and
the
that's,
other one.
yes, and that's what I'm going to do now.
Okay.
Let's see, what was it? Negative X, where did it go? +2. All right. So instead, let's make a table. And how about if we use X is 0 and X is 1? Okay. If X is 0, let's see, I've got Y equals negative X plus 2, right? Because f of X is the same thing as Y. So Y equals negative 0 plus 2, which is 2. So 0, 2, there's 1 point. When X is 1, Y equals negative 1 plus 2, which is 1. So when X is 1, Y is 1, there's the second point, 1, 1. And so there's my graph, and notice it's the same graph. Okay, so either way, slope intercept form is often quicker, but if you're not real solid with it, ordered pairs is just fine too. All right, do you want some more of those?
No, I got it. Thank you.
Okay. Who's next? What do you got for me? Bring it on. All right, let me remind you of some things that came out in this chapter. And this is actually in 8.2. Okay. We had this idea of slope intercept form. We also had the slope formula. We also had parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Let's see, what else? Oh, y equals a number is the equation of a horizontal line. Let's see. Yeah, okay. So we had those things. Does anybody need any examples where that one of those rules is used? Again, this goes back to 8.2. Okay. Let's see here. You know how to tell whether something is a function or not?
Yes.
Could you show us?
Sure. Okay. Let's do let's see. Let's do ordered pairs, or let's see, let's do a table. Okay, how about this? Function or not?
Yes.
Yes. You can have two inputs with the same output, just like you can have two people with the same birthday. So yes, that is a function. Okay, what about this one? Let's see. Function or not?
not.
Why not?
There's two X inputs that share different Y outputs.
Careful, you said that backwards. Fix it. There's two, you said there's two inputs that share the same Y output. You've got two, you can say it. You can do it.
Two outputs.
There you go, that share the same input. So you've got 0 goes to 8 and 0 goes to 3, so not a function. There, that's function. Can you tell? Because one input can't go to more than one output if it's a function. One person doesn't have two birthdays. It sure seems like a Monday to me anyway. Okay, we all right with that?
Yes. But can we practice more variation methods?
Sure. Okay. Do you want just more of the stuff from WebAssign, or me to just give you some other ones? What do you want?
Whichever.
Okay, let me just pull some out of the book. That's easier, then I don't have to go back and forth between the two screens and confuse all of us. Okay, so let's see here. All right. The distance that a car can go varies directly as the number of gallons of gasoline it consumes. If a car can go 288 miles on 12 gallons of gasoline, how far can it go on a full tank of 18 gallons? All right. The distance that a car can go varies directly as the number of gallons of gasoline it consumes. So we're going to let D equal distance and G equal gallons of gas. Okay. The distance that a car can go varies directly as the number of gallons of gas. So D equals kg. Any questions about where I got the direct variation formula? All right. If a car can go 288 miles, so D is 288, on 12 gallons of gasoline, so G is 12, I can stop there and go back and determine what K equals by taking 288 divided by 12, which is 24. So now that goes up here and my formula becomes D equals 24G. Okay. Then it says, how far can it go on a full tank of 18 gallons? So D equals 24 times 18. 24 times 18 equals 432 miles. Any questions on this example?
No.
Let me ask you this. This number we came up with, 24, what does that represent? And I know it's the variation constant, but what does that represent in terms of the vehicle traveling, and et cetera, et cetera? Anybody? This vehicle gets 24 miles per gallon. That's its, I don't know, its gas mileage rate kind of thing. Because if you take 24 miles per gallon times the number of gallons, you're going to get the total distance. I don't know if that makes sense or not, but anyway. Okay, another example. Let's see here. Gas pressure under constant temperature the volume occupied by a gas varies inversely to the pressure applied. Okay, so V is going to be volume and P is going to be pressure. Okay, under constant temperature, so the temperature doesn't change, so we don't use that in the formula. The volume varies inversely to the pressure applied. Any questions on how I got that so far? If the gas occupies a volume of 20 cubic inches under a pressure of 6 pounds per square inch, so now I've got everything but K, I can come back and say, oh, we're going to multiply both sides by 60, or excuse me, 6, and I get K equals 120. That goes in the place of K up here. So now I've got this formula. Find the volume when the gas is subjected to a pressure of 10 pounds per square inch. So find V when P is 10, which becomes 12 cubic inches. This is just like when we did earlier from WebAssign. Earlier today, that is. We all right with that?
Yes.
Okay. Let's see here. Let me ask you this. This is more thinking than calculating. Is there a direct variation or an inverse variation between each pair of quantities? Okay. Now, recall, direct variation, if one goes up, the other goes up. If one goes down, the other goes down. Inverse variation, if one goes up, the other goes down. Okay. Says the time it takes to print a term paper and the speed of the printer. So if the speed of the printer increases, will the time it takes to print increase or decrease? If the printer goes, what's that?
Increase?
If this printer goes faster,
Yeah.
would it take more time or less time to print the document?
Less time?
Less time. The faster it goes, the less time it'll take. So if you increase the speed of the printer, it decreases the time it's going to take. So is that direct or inverse?
Inverse.
Okay, good. How about this one? The time it takes to print a term paper and the length of the term paper. So if the term paper is longer, will it take more time to print it or less time?
More time?
Right, so they are they direct or inverse? They're direct. Good, good. Okay, is that making sense? Nobody's saying yes?
Yeah.
How about this? Who here drinks latte or goes and purchases lattes? Anybody? Nobody purchases them? Okay, well.
Yeah.
Yeah, you do. Okay, what do you pay?
$4.25 probably.
Okay, you pay $4.25. How many a week?
3?
Okay, so we'll say cost and number. All right. What if the price went up to $6? Would you still buy 3 a week?
No.
How many would you buy? Would you buy 2?
Probably 1.
Probably
2,
1?
yeah.
Just one? Okay, all right. So what happened here? The price went up, the amount you would purchase went down. Is that direct or inverse?
Inverse.
Good, good. Okay. I want somebody to come work for me and you're going to weed my garden, okay? And we're going to say this is going to be hours worked and pay, all right? And let's say you work 3 hours, I'm going to pay you $60, okay? If you work 5 hours, I'm going to pay you $100. Is this direct variation or inverse variation?
Direct.
Well, why? You're correct. Why is, how do you know?
Because it's the same amount per hour.
The more you
The
work,
more
money
hours.
you.
Wait, you're right. It is the same amount per hour, but what is the amount per hour?
20.
So that's K, isn't it?
Yeah.
But what happened?
They both increase.
Right. So they both increased. If the number of hours goes up, the amount of pay goes up. What but if you only work 1 hour, I'd just give you $20. So if the amount of hours goes down, the pay goes down. So that's direct variation.
Yeah.
You got it? Maybe? Okay. You need some more of those or not? Everyone's the silent type. What's that? You're good? Okay.
Yeah.
What else? Anybody? Anything you want to look at?
I have a question.
Yes.
Hopefully I can explain myself well. So when you're doing the inequality, the graph, the line graph, how
Yes.
do you know when to do a square bracket or a dot with the circle? Because both of them represent the same, right?
Okay. Okay. There's your answer. In other words, if it's filled in, you would have a bracket. If it's an open circle, you'd have a parentheses, okay? And I can't remember if WebAssign accepts both of them, but I know in the book they use this notation. Okay, so let's say, for instance, I've got the following situation. I've got 3 less than or equal to x less than or equal to 10, okay? And I've got that situation. So the interval notation would look like this, and the graph would look like that. So I'm going to have a bracket at 10 and a bracket at 3 with it filled in between. Okay, does that make sense?
Yes.
Now, what if we did this instead? Okay, so I changed that. I got rid of that one. Now it would look like that. And it would be parentheses at 3 and a bracket at 10. Okay.
But if for some reason WebAssign didn't accept the dot or the brackets you used, but it's the right ones and it gets it wrong, will we still get the points?
Say that again. If
Like
WebAssign,
say they didn't accept the dot ones, but
yeah.
it was the correct answer and everything, would we still get it right?
Well, I guess that's going to be a judgment call on my part, because really what I've been teaching you was using the parentheses and the brackets. So that's really what I want you to use. Okay.
Okay.
And something that came up yesterday again was a student asking, and I emphasized this when we were graphing the inequalities, but I know not everybody watches the videos, and sorry for them, but WebAssign does something that's kind of tricky, and it's not my choice. I would do it differently, but this is how it works out. For instance, there was a problem where, let's see, this was 0 and this was -5, but they had it divided into 4 equal parts. And that's confusing. You'd think they'd had divided into 5 equal parts. So each one of these, this is like -1.25, this is -2.5, -3.75. And what the person did is, I think they counted backwards. They said, well, if this is -5, this is -4, and this is -3. So they graphed it at this being -3 when it isn't -3. You've got to look at the scale, okay? You've got to look at the scale because they aren't as nice as they could be. The other thing is, because I played around with it a little bit, and if you're really close, it tends to count it right, because sometimes you have to estimate. For instance, here, how would you estimate -3? Well, let's see. If this is -2.5 and this is -1.75, wow, so that's like 1.25, and so it's going to be, you know, right about here, about being the key word. And here's a case of where if you are close and it marks it wrong and I look at it, I will give you credit if you are close, but you've got to be, it's got to be a reasonable estimate, but you've got to look at the scale, okay? Look at how many little hash marks there are. Are each one of those a 1, or are they a 1.25, or are they a half, or are they 3? You got to pay attention to the scale, okay? I wish they were nicer than that, but they aren't. What else? Anything else you want to look at? Okay, well then I'm going to close up this session. So I'll stop the recording.